Hello and welcome. In this series, let's talk about object-oriented programming, better known as OOP. In this intro to OOP, we are going to discuss structured programming and object-oriented programming. OOP took the best ideas from structured programming and combined those ideas with a few new concepts. We have the option of organizing our program around the code, or we can organize our program around data. Structured programming is organized around code, while the OOPS concept is organized around data. My name is Rex, and I like to share programming and automation knowledge. If you're interested, connect with me on YouTube, Twitter, LinkedIn, Facebook, and GitHub. All of the documents, including the transcript, will be placed on GitHub. Videos are released 3 times a week on Monday, Wednesday, and Friday. When it comes to structured programming, the programmer divides the whole program into smaller units. For example, let's take an employee working at a company. First, they submit the resume, attend the interview or interviews, gets hired at the company, perform their job responsibilities, then receive a paycheck. The big program is divided into small units such as calculate salary, calculate bonus, and calculate health benefits. That's what we call code acting on data. Object-oriented programming is different. With this same example of an employee working at a company, our program has a class called employee. It's organized around data, and the data controls access to the code. We define the data, and we define the methods that are allowed to act on the data. The data is age, employee ID, and title, while the methods are calculate salary and calculate bonus. Here's a side-by-side comparison of structured and object-oriented programming. There was a point when structured programming reached its limit and could not handle complex applications. Object-oriented programming was created to help developers deal with more and more and more and more challenges as the software application grew. The OOPS concept deals with complex application using classes and objects. Our class is employee, and our objects are Jane and John. Classes are the foundation which builds the entire Java programming language. Also, classes define the nature of an object. In other words, a class is a copy or a template for an object. The same way class has age, our object Jane has age, and the value is 25. Just like the employee class has employee ID and a title, Jane has employee ID with the value of 34 and automation engineer as the title. The same goes for each method, calculate salary and calculates bonus. Jane has access to both methods, calculate salary and calculate bonus. We see how a class serves as a pattern for creating the object. In the same manner, our object John has access to the same data and methods. All object-oriented programming languages have 4 common traits. Those four traits are encapsulation, inheritance, polymorphism, and abstraction. In some cases, you might see some people say all OOP languages have three common traits: encapsulation, inheritance, and polymorphism. Abstract classes, abstract methods, and interfaces falling under inheritance. The concepts remain the same, so it does not matter where we place them, as long as we understand the concepts. Encapsulation is a way to protect the data by keeping it safe from outside classes. It can only be accessed through a method within its own class. Inheritance allows a hierarchy creation of classes. It's a component where one class is an extension of a different class. The class that is extended is called a superclass, and the class that extends is called a subclass. However, I prefer to say parent class and child class. A child class receives the data and methods from the parent class. This incorporation happens in the declaration of a child class. Polymorphism means many forms. It allows an object to acquire many representations. All of those representations operate similar to each other. As a result, one interface has the ability to take on properties of more than one class. Abstraction is when the necessary details are made available. Abstract classes create a parent class that specifies only a general form shared by the child class. An abstract method contains no body and not implemented by the parent class. That's it for the intro to OOPS. Next, I will demo encapsulation. Encapsulation is the process of protecting the internal representation of an object. It's known as data hiding because we make the data private, so the data cannot be accessed from outside the class. Hi, my name is Rex, and I like to share programming and automation knowledge through books, blogs, and videos. If you're interested in the content, feel free to connect with me on LinkedIn, YouTube, Twitter, Facebook, and GitHub. Let's go to Eclipse. We have a class called employee with the double data type for salary and bonus. The method calculate total pay performs an action on the data by adding salary plus bonus, then assigning the value to total pay. Let's look at why we need to protect our data. In this class called test employee object, Jane's salary should be set to $100,000 and bonus set to $10,000. However, check out what happens when we calculate total pay. Jane made over $1 million with a total pay of $1,010,000. The salary is not correct at $1 million. This is a prime example on why we need to protect our data. A person can make a mistake and enter the wrong data, so we protect the data using a private access modifier with getter and setter methods. A getter method is used to get and view values, while a setter method is used to set or modify a value. Let's say the company's policy is no employee gets paid less than $50,000. and no employee gets paid more than $250,000. We protect the data by changing salary and bonus to private. Then save. Do you see how instantly Jane.salary and Jane.bonus both have an error? They have an error because they are no longer visible. Next, we create a setter method for salary. Let's start with salary. We write public void set salary. The parameter will be double salary inside the parentheses. And if salary is greater than or equal to $50,000 and salary is less than or equal to $250,000, this dot salary equals salary. Else, this dot salary equals $0. Let's add a print statement. Sys out. Salary is incorrect. The keyword this for this dot salary refers to the field private double salary and not the parameter salary in parentheses. Now we have a boundary for setting our salary. For bonus, there is no limit. So I'm going to create a setter method by writing public void set bonus double bonus as the parameter. This dot bonus equals bonus. In the test employee object class, we must call the methods by writing Jane dot set. The IntelliSense shows set bonus and set salary. Select set salary. Then pass $1 million again as an argument. Also write Jane dot set bonus. Then pass $10,000. Let's run. We protected the salary, so the console shows salary is incorrect. Change $1 million to $100,000 and run. Now salary is correct. The console shows total pay equals $110,000. How can we print the salary and or bonus from the test employee class? Sys out. Jane's salary equal Jane dot. We know the data is not available because it's private. That's where the concept of getter methods come to action. It will help us get the data. We write public. Since the data type is double for salary, then the return type is double. get salary as the method name, no parameters, and we're going to return salary. From the beginning, if you did not want to write each getter and setter method, then Eclipse can generate both methods for us. Right click, select source, then generate getter and setters, then check bonus, and click OK. There it is. Public double, get bonus, and return bonus. Now let's finish our print statements. Jane dot get salary, and sys out Jane's bonus is Jane dot get bonus. Let me go save over here. Bingo. Now let's run. There it is. Jane's salary is $100,000. Bonus is $10,000, and total pay is $110,000. Bingo. Next, we're going to look at inheritance. Inheritance is when a class receives the members of another class. It allows us to extend a class, then reuse the code. We create a generic class and specialized class. The generic class defines the common traits that will be inherited by a specialized class. In Java, the inherited class is called a superclass, also known as parent class. The special class, which receives an inheritance, is called a subclass, also known as child class. Hi, my name is Rex, and I share automation and programming knowledge. In this video and the next few videos, I am going to share knowledge on Java programming. If you're looking to learn or refresh your knowledge, then connect with me on LinkedIn, YouTube, Twitter, Facebook, and GitHub. You can download the code and each transcript from GitHub. With object-oriented programming, inheritance is known for representing an is-a relationship. For example, an employee is a person, so the employee class can be a child class of the person class. In the same way, a student is a person, and student can be a child class of the person class. With this hierarchy, the person class is the parent of two child classes, employee and student. The child classes can become a parent to other classes. When it comes to sharing data, both child classes and each grandchild inherits from the person parent class. Let's say the person class has a variable called a name and a method called getName. From left to right, the employee, student, manager, team lead, graduate, and undergraduate classes inherit those same members from the person class. In Eclipse, we are going to write two variables for the person class: private string name and private string date of birth. Next, let's add the getter and setter methods by right-clicking, source, generate getters and setters. Expand both checkboxes. Eclipse will automatically add these 4 getter and setter methods. Check date of birth and the name. Then click OK. We have all 4 methods. Next is the student child class. The purpose of inheritance is to reuse code by extending a class. Therefore, student extends the person class. The keyword extends produces an inheritance relationship between student and person. If I click Control Space, we see all of the methods from the person class. The student class inherited get date of birth, get name, set date of birth, and set name. Notice we do not see the private variables name and date of birth. They cannot be seen or accessed by the child class. Inheriting a class does not overrule the access restriction for private properties. Private properties are not visible by outside classes. One of the benefits of inheritance is the public properties of a parent class can be shared by all child classes. After receiving the public properties, a child class can add its own unique members. Now, we're not concerned about creating a variable and method for name or date of birth in the student class. This helps the student class focus on specialized variables and methods that are only used by a student. For example, we can write private int student ID and private string class name. The student ID and class name are special to the student class. Generate the methods again by right-clicking, source, generate getters and setters. Check both boxes and click OK. We have our methods. We have our parent class and child class. The next class, test inheritance, will access both classes. We create a person by writing person equal new person. A student is created by writing student equal new student. The person object dot has access to all 4 methods defined in the person class. Let's select get name from the person class. The student object dot has access to all 8 methods, which are defined in the person class and student class. Let's also select get name. Do you see how we have access to get name? That's why we are not concerned about the variable being private, because the data can still be accessed through a getter method. How about both methods from the student class? Student dot get student ID and student dot get class name. This is a perfect example of inheritance where the child class receives members from a parent class. Next, we will take a look at polymorphism. Polymorphism is closely related to inheritance. You know how inheritance represents an is-a relationship? Polymorphism also has that same kind of relationship. So undergraduate is a student and student is a person. Therefore, one instance, such as undergraduate, can pick up the behaviors and attributes of more than one class. That's how polymorphism maintains the capacity to take on many forms. With this diagram, undergraduate has three forms. Undergraduate has the form of a person, undergraduate has the form of a student, and undergraduate also has the form of its own type, undergraduate. There are two ways to implement polymorphism: method overloading and method overriding. Method overloading involves the same class, and method overriding involves different classes. In this polymorphism session, we will investigate method overloading, method overriding, and both Java bindings. Method overloading refers to static binding, while method overriding refers to dynamic binding. Let's start with method overloading. In Java, method overloading is when more than one method has the same name but different parameters. Go to Eclipse. We see two methods named add. However, there's an error. The error states duplicate method add int in type overload. That means both methods share the same name and share the same parameter declarations. To overload a method, the parameter list must be unique. The type and or number of parameters must not be the same. Let's start with the type. Change the second type to double. Include double in the print statement. Save, and the error goes away. Copy and paste. We can also swap the types. Int and double to overload a method. Also swap in the print statements. Double, int. All three methods have a unique order of types. First method, int. Second method has int double. And the third method has double int. Now, let's look at the number of parameters. Copy and paste. Then add int num3. We see every way to overload a method because the type and or number of parameters are unique. Also update the print statement to int numbers and include num3 in parentheses. The return type has no impact on overloading a method because Java does not decide which method to execute based on the return type. If I copy and paste, then change the return type to int. Remove the print statement. Then assign num1 plus num2 plus num3 to int sum equal. Print statement sys out add 3 int numbers equal plus sum, and return statement sum. Hover both arrows and they show duplicate method add, double int in type overload. The return types are different, but they're still an error. A difference in return types cannot be used as an overload method. Change the first type to int. And now we have our overloaded method. A constructor can be overloaded by using this same principle. Next, we will take a look at method overriding. Cool. Method overriding allows a superclass to specify a method that will be common to all subclasses. Combining inheritance with method overriding satisfies the one interface, multiple methods aspect of polymorphism. A superclass defines the general method that can be used by all of its subclasses. Each subclass is flexible to define its own specialized method while enforcing one consistent interface. Method overriding only happens when a method in a subclass has the same return type and signature as a method in the superclass. In our diagram, student is a child of the person class. It's also the parents of graduate and undergraduate. In real life, graduate is a student who has a bachelor's degree and pursuing a master's or doctorate degree. An undergraduate is a student pursuing a bachelor's or associate degree. Both children classes will automatically inherit the same student method if the method is public. In this session, we already have a person class and student class from the previous inheritance section. The student class extends person. Let me minimize these getters and setters. For starters, I will create a method to calculate the grades for each student. Public int, calculate GPA. We have to create an array to store a list for the grades by writing private int grades. This method returns 0. Now let's calculate the GPA. First, we initialize int sum equal to 0. Then a for loop. Int grade colon grades. Sum is assigned to sum plus the next grade. Return sum divided by grades dot length. Length provides the number of elements in the array. Add getter and setters. Source, generate getter and setters. Select grades, then OK. Here it is. Let's imagine graduate students only get credit for grades 75 and above. Start with a private int field called minimum grade equal to 75. In addition to minimum grade, we need a specialized method only for the graduate class. This method will override the method in the student class. With inheritance, graduate extends student. Control space. Do you see the calculate GPA method and these other methods that override a method in student, we also see some override methods for the person class. Select calculate GPA and erase the comments. It's not required, but it's recommended we use this override annotation method, override annotation, to prevent an error such as providing a different method name. Now, let's calculate the GPA based on grades 75 and higher. Int sum equal 0. For int grade, call the get grades method from the student class. If the grade is greater than or equal to minimum grade, then sum plus equal grade. This is the shortcut syntax for sum equals sum plus grade. Return sum divided by get grades. Bad typing. Let me try it again. There it is. Get grades divided by length. Okay. This, error. Had to save. You see here, students not saved. But when I save, it goes away. This calculate GPA method is how we implement a specialized method for a child class to override its parent class. Next, we're going to look at the difference between both Java bindings. The Java bindings are static and dynamic. Static happens at compiler time, while dynamic happens at runtime. Method overloading is an example of static binding, and method overriding is an example of dynamic binding. Let's start with the static binding by testing all 5 of these static overloaded methods. Static means they are shared between the whole class. As a result, static methods are bound to their implementation at compile time. The methods can be called directly by its class name. Therefore, it's not important to create an object to access the 5 static methods. We can write the class name overload, and we see all 5 methods. Select double int, then write 10.0 and 5. Next is overload dot int double and write 5 15.0. Third method is overload dot int. Let's write 5. Number 4 has 3 methods, 3 parameters. Overload dot double int, then write 20.0, 20, 10. The last method had an int return type. Overload dot. Do you see how 4 methods have void as their return type and 1 method has int? Write 50, 50, 50. Let's run. We see a print statement for each overloaded method. Java restricts static methods from being overridden. Dynamic binding allows for overridden methods, which are multiple implementations that can be called depending on the instance. For example, let's think about the calculate GPA methods from the student and graduate classes that we did in the previous session for method overriding. We can use a separate implementation for student and graduate. However, I am going to implement one graduate and another one for undergraduate. Recall, graduate has a method to override the student method. Undergraduate does not have a method to override student, so it will use the method created in the student class. Here's a scenario with two instances. Jane is a graduate and John is an undergraduate. We are going to imagine both students have 7 grades and the same grades for each class. They have 7 classes and the same grades for each class. The difference is John gets credit for every class, but Jane only gets credit for classes 75 and above. We have a field for minimum grade equal to 75 and a calculate GPA method. Let's create an array for grades. Int grades equal. Let's assign 7 grades. 95, 100, 95, 74, 75, 89, 90. 1, 2, 3, 4, 5, 6, 7. Bingo. Now our objects, student Jane equal new graduate. Jane, typing is not going good today. I guess that's the catch of doing it live. Set grades, pass in grades. Okay, the next student is, student is John, new undergraduate. There it is. Set the grades for John by writing John dot set grades. All right, okay, now we're in business. Both students have the same grades, but Jane gets credit for 6 of the 7 grades. She does not get credit for the 74. Let's print the grade point average. Sys out. Jane's graduate GPA, Jane dot calculate GPA. Sys out. John's undergraduate GPA, John dot calculate GPA. There it is. Let's break this down before I run. Here's what's going to happen. When I execute dynamic binding, we'll look at the graduate instance type for Jane, then call the override GPA for calculate method in the graduate class. For John, the instance type is undergraduate, but the undergraduate class does not have an override method to calculate the GPA. Therefore, it will use the calculate GPA from the student class. Let's run. Jane's GPA is 77, while John's GPA is 88. The console shows a different GPA for Jane and John, although both students have the same grades. That's what we call dynamic binding. We are finished with polymorphism for dynamic binding, static binding, method overriding, and method overloading. In the next session, we will dive into abstraction, and hopefully I'll type better in the next session. In general, abstract indicates a feature or part from a particular object. When it comes to object-oriented programming, abstraction serves as a representative for real things. For example, we have a class named cat that's abstracted into a type. Next, we declare a field named breed in the cat class. Breed is a real characteristic that we can abstract from a cat. Last is the behavior action of a cat. We abstract meow as a real action for a cat. With this example, abstraction shows the necessary features of an object. Cat is an abstract concept because it displays a general characteristic and a general action. As a result, the type is a cat with the breed characteristic and meow as an action. Did you notice the keyword abstract? Abstract is a non-access modifier for classes and methods, but not for a variable like breed. The purpose of abstraction is to define a template for a class or define a template for a method. Abstract classes are generic and operate as a superclass. Therefore, it can be extended, which allows a subclass to fill in the details. Abstract methods are also generic. They are designed to be overridden in the subclass. That's why we only see the signature of the method: abstract, void, meow, parenthesis, semicolon, and nobody within the curly braces. The details are implemented in the subclass, which overrides the abstract method defined in the superclass. Static methods and constructors cannot be abstract. Java also provides an interface, which is similar to an abstract class. One of the differences between an abstract class and interface is an abstract class can have abstract methods and fully defined methods. The fully defined methods are instance methods, which provides a default action. Traditionally, with an interface, there was no way to supply a default action. All of the methods were abstract before Java Development Kit JDK 8. Now we can define a default method to provide a default action. The primary motivation for default methods was to deliver a way to enhance interfaces without breaking existing code. Next, I am going to demo abstract classes and abstract methods. An abstract class is a class with empty methods and optional concrete methods. The empty method is an abstract method, and the concrete method is an instance method with fully defined details. In this example, we see two diagrams, a square and a rectangle. To calculate the perimeter, we can define one generic abstract method in the superclass, then let the subclass for square and subclass for rectangle provide details on how to calculate the perimeter. The calculations for square are 4 times the side, and rectangle is 2 times length plus 2 times width. It's a difference because the square is the same on each side, but rectangle has a longer length than width. Let's go to Eclipse and create a class and method. The class will be public abstract class shape, and method is public int calculate perimeter. There it is. Hover over the compile time error and the message states this method requires a body instead of a semicolon. We have a semicolon because the plan is to not add a body. Now, they offer us 2 quick fixes. We can either add a body or change shape.calculate perimeter to abstract. Add abstract before the return type abstract, and the error goes away. Let's see what happens when removing abstract from the class. Now there are 2 errors, one at the class level and another one at the method level. Hover the method and we see the abstract method calculate perimeter in type shape can only be defined by an abstract class. If we have 1 or more abstract methods, then we must make the class abstract. That's why we see the following quick fixes. Remove abstract modifier and make type shape abstract. Hover the class and we see the type shape must be an abstract class to define abstract methods with 1 quick fix. Make type shape abstract. Let's re-add abstract. Finally, the errors go away. Recall, an abstract class is a class with an empty method, which means the method is abstract, just like calculate perimeter. And it is not required to have a defined method, meaning the method has a body. Let's add a defined method, which is an instance method. Public void print shape message. Sysout print perimeter. Skip a line. Next, we are going to create 2 subclasses that will provide details for this calculate perimeter method. Starting with the square class, it extends shape superclass. Instantly, we see an error. The type square must implement the inherited abstract method shape.calculate perimeter with 2 quick fixes. Add the unimplemented method or make type square abstract. If we are not going to implement the abstract method, then we must make the square class abstract because the superclass contains an abstract method. Select add unimplemented methods and we see override annotation, which indicates the calculate perimeter method is overridden. Remove the comment, then implement the details. Private int side equals 10. Method details are int perimeter equals 4 times side. Sysout square perimeter. I almost spelled that wrong. Append the perimeter. Okay. Return perimeter. Okay. All right. The rectangle class is similar to the square class, but has different details for the calculate perimeter. Rectangle extends shape. Private int length equals 5. Okay. Private int width equals 10. At override annotation, public int calculate perimeter. I almost spelled it wrong again. Int perimeter equals 2 times the length plus 2 times the width. Okay. Sys out, let's write rectangle perimeter equals perimeter. Okay. Return perimeter. Okay. If necessary, you can also create a constructor in an abstract class. That's it for creating an abstract class and abstract methods in a superclass with subclass implementing the details for calculate perimeter. Now let's test out the code in the shape test class. Write main control space for the shortcut. With abstraction, we cannot create an object of abstract classes. Our abstract class is shape. Let's add shape as an object equals new shape. A compiler error states cannot instantiate the type shape. Comments this line and say abstract classes cannot create an object. There are no objects of an abstract class because abstract classes do not define a complete implementation. However, we will not get an error by declaring a reference of the abstract class. Shape. Shape1 equals new square. Or shape2 equals new rectangle. I spelled that wrong. Gotcha. These two syntaxes are good because the square type and rectangle type are not abstract classes. We can also declare reference of the child class. Square equals new square. Square dot. And we see calculate perimeter from the square class and print shape message from the shape class. Notice we do not see the calculate perimeter from the shape class. Select both messages, both methods, print shape message and square dot calculate perimeter. Rectangle. Rectangle equals new rectangle. Did I spell that right? Okay. Rectangle dot calculate perimeter. It's not required to include the instance method, which provide a default action. Let's run. The console shows print perimeter, square perimeter equals 40, and rectangle perimeter equals 30. Next, we're going to look at interfaces. An interface is a contract with the class. Contracts are agreements for doing something or not doing something. So the contract between an interface and class is the interface specifies what a class must do, but not how the class must do it. Here is the syntax for an interface. All interfaces have the keyword interface before the interface name. The scope must be public or package. In this example, the scope is public, but if we do not define a scope, then the default scope is package. Every field in an interface must have a constant value. Therefore, the variable is implicitly public, static, final, and requires a value. In this example, I did not include those three keywords, public, static, or final. However, Java will still treat int hours in a day equal to 24 as a constant because interfaces are contracts that cannot hold state. That means not allowed to change its behavior. So we should not add a variable if the value is going to change. When it comes to methods, they cannot be abstract, static, or default to an implementation. Notice the method void calculate hours does not include the abstract keyword and it does not include a body. It does not include abstract or a body because the interface assumes all methods are abstract. As a result, the abstract keyword is not required. Since the interface has a contract with the class, there is a guarantee that each abstract method listed in an interface will be implemented by the class. Static methods and default methods are not required to be implemented by a class because they already have an implementation. Two of the benefits for using an interface is to bring consistency for all classes that implement an interface and the support of multiple implementation. My plan is to demo both benefits by starting with consistency for all classes. Let's look at two email service providers, Outlook and Gmail. With Outlook, we see a lot of functions such as file, home, send receive, folder, view, and help. If we wanted to create a new email, we can click new email. If we wanted to close, we can click X in the top right corner or go to file, then click exit. Those same functions are available with Gmail and other email service providers. In Gmail, to create a new email, we select Compose. It's the same function in Outlook, but just a different name. The spam folder is used to store emails that we don't want in our inbox. Outlook has this same function, but it's called junk. Although both providers have functions that operate the same, the name is different and implementation details are different. For consistency, we can create an interface so Outlook and Gmail have the same name with their own unique implementation. Outlook has three methods: new email message, open junk folder, and close Outlook. Gmail also has 3 methods, but different names. Compose email, open spam folder, and close Gmail. Recall from the introduction, an interface is a contract with the class. It's an agreement that determines what a class must do, but not how the class must do it. Therefore, both classes will have the same method name, but different details. To create an interface, we go to New, Interface. The name will be Email Service Provider. Then click Finish. It looks like a class, but we see public interface and not public class. We create a method by writing public void, then the method name, create email message, add a semicolon. Writing keyword abstract after public is optional. As a convention, we do not write abstract. It's an assumption that all methods in an interface are abstract, although we can write default methods and static methods. For example, if I remove the semicolon, then add a body, which start and stop with the curly braces. An error states, abstract methods do not specify a body, but it shows us 3 quick fixes, which include changing the method to default or static. Remove the braces, then add back the semicolon. Abstract methods define the signature of a method, but no implementation for the method. Some more methods that we can add to this interface are public void, open junk spam folder, and public void, close email provider. So this interface says all implementation classes should be able to create an email message, open a junk spam folder, and close the email provider. Now let's implement the interface. Go to Outlook and write implements email service provider. Instantly, we see an error. The type Outlook must implement the inherited abstract method email service provider. Open junk spam folder. All 3 methods are recognized as an abstract method. The 2 quick fixes are add unimplemented methods and make type Outlook abstract. Let's add the unimplemented methods. We see each method from the interface email service provider with an override annotation. This is where the Outlook class can implement its unique details for each method. I'm going to copy and paste the print statements. Outlook, new email. Outlook, open junk folder. And Outlook, close email. The same for Gmail. It implements email service provider, and this time let's make the type abstract. The keyword abstract is added before class. We should not make the class abstract because it can lead to an error when creating an object. Objects cannot instantiate an abstract type. Remove abstract, save, then select add unimplemented methods. Also copy and paste the print statements Gmail compose email. That kind of rhyme, don't it? Gmail open spam folder. And Gmail close email provider. The contract agreement between the interface and each class has been fulfilled. Look what happens when the interface breaks the contract agreement by adding another abstract method. Public void save draft folder. Then click save. We see an error in the Outlook class and Gmail class. The error exists because both classes was now part of the original agreement with save draft folder. To solve this error, we can do one of two things. First, we can go to each implementation class and implement the abstract method. But what if our program had more than two classes? What if I wanted to add another method later on? I prefer option 2 and extend the interface. Java allows us to extend the interface so we don't have the fear of breaking an implementation class by creating a default method. The key is to add default and include a body. There will be an error if we only add default. The error states, this method requires a body instead of a semicolon. Add a print statement for the body, sysout, save, draft. Skip a line, then save. Both errors are gone, but if we wanted to, we could override the default method. However, when it comes to a static method, it provides a protection for an interface. It provides protection by not allowing an implementation class to override the static method. You can watch the Java Bindings video where I speak about how Java restricts static methods from being overridden. We can write public void sent email folder. Public static void sent email folder. Sysout sent email. Let's test the interface and both implementation classes. Go to new class, main test email service provider, then finish. Email service provider, object outlook equals new outlook. Outlook dot. And we see 4 methods, all 3 abstract methods and the default method. Close email provider, create email message, open junk spam folder, and save draft folder. Select the open junk spam folder, but do you see how the static method is not here? Outlook dot create email message. Outlook dot close email provider. Outlook dot save draft folder. We can write the same for Gmail. Email service provider, Gmail equals new Gmail. Gmail dot open junk spam folder. Gmail dot create email message. Gmail dot close email provider, and Gmail dot save draft folder. Let's run. We see 8 methods, 8 print statements, 4 for Outlook and 4 for Gmail. Next, we're going to look at how interfaces support multiple implementation. Multiple implementation of interfaces is a way for a class to implement more than one interface. That's important because inheritance cannot extend more than one class, but an interface can extend more than one interface. In this diagram, we see one superclass and 3 subclasses. Each subclass inherits the superclass. Let's look at this diagram using a store example. Store is the parent class, while food store, clothes store, and medicine store are the child classes. With inheritance, there is no way to combine all stores into one combo store. It is impossible because we are not allowed to extend more than one class. This is called a diamond problem. Do you see the diamond? Combo store will not inherit food, clothes, or medicine, although it's possible in real life. However, we can combine all stores when one class, which is combo store, implements more than one store. There is no limit to the number of interfaces a class can implement. In Eclipse, we see the food store has 2 abstract methods, sell fruits and sell vegetables. The medicine store also has 2 abstract methods and 1 default method. Sell prescription and sell vitamins are the abstract methods. Pay cashier is the default method with details to pay a pharmacy technician. Clothes store is similar to medicine store. It has 2 abstract methods, sell shoes and sell shirts, and the same default method named pay cashier, but different implementation details. To combine all 3 interface stores, we go to the combo store. Then it implements food store, clothes store, and medicine store. Just like when implementing one interface, we must add all unimplemented methods. There should be 6 overridden methods. Sell prescription, sell vitamins, sell shoes, sell shirts, sell fruits, and sell vegetables. Save, and there's one more error. Duplicate default methods named pay cashier with the parameters that's blank and are inherited from the types medicine store and clothes store. For a quick fix, we can override the default method name or change the parameters. This is also a diamond problem because both interfaces have the same default method name payCashier, and the compiler cannot decide which super method to use. Override payCashier from close store. Go to the method and we see override close store.super.payCashier. Recall that a class cannot extend more than one class, but an interface can extend more than one interface. Let's go to the food store interface. It extends another interface called email service provider, which is another interface from the previous session, how to implement an interface. Save and combo store will have a different error because the abstract methods from email service provider must be implemented. Add unimplemented methods. Then go to the bottom and we see each method. Create email message, open junk spam folder, and close email provider. In this example, multiple interfaces are extended after adding a comma and another interface name. The interface is day. It extends two interfaces, week and month. That completes the Java Object-Oriented Programming series. We covered 4 traits of the OOPS concept: encapsulation, inheritance, polymorphism, and abstraction. I hope you learned something from this OOPS series. If you did, subscribe, connect, and follow me because I have so much more content to share with our testing community. And I'll see you in the next video.
Books available in paperback, ebook, and PDF. All Part 1 ebooks and PDF documents are free. Programming books for UFT. Programming books for Java. Here's the Selenium Automation book. And TestNG. Subscribe to get notification of future videos. Don't forget to like, comment, and share.